In this demonstration, I would like to develop the algorithm for the sum of arithmetic progression. So which is written as plus a plus t plus a plus 2d and plus a plus 3d. And for n terms, the final term becomes a plus n minus 1 times d. So this is the arithmetic progression. This is arithmetic progression. Okay. So we can recognize there is summation. We can identify this is the second term, this is the third term, okay, fourth term, and all that. So we can also say that it is A1, A0 plus A1 plus A2, and so on. Okay, plus A, since I started with A0, so I should call it AN minus 1. We can recognize that there is a pattern that A1 is equal to A0 plus D, right? And then we recognize that A2 is A1 plus D. So we can move further, right? So in our algorithm development, we would like to calculate the final summation, right? We can start with the first value A or A naught, right? In my development, A naught is equal to A. The other distinct feature is the common difference, right? So difference is D, and I have to calculate the summation. So this is going to be our output. This is going to be our output, and these are the inputs, and also the number of terms to be calculated in this sequence that can be considered as input provided inside the program, or it can be read out during the program execution, right? So we can make that one generic like this. So we have understood we can define the variables. Okay. So okay, the calculation sequence should start that with the variables, like input and output specification. We will initialize our summation to 0, the first value, like in the demonstration of picking up the things and calculating the weight. I started with the empty bucket, right? So the first member has been initialized. So we will say, okay, A equal to A naught and D equal to D naught. This is going to be the initialization. This is the initialization. And then we can recognize that the sum must be updated to the new term. So I say S equal to A naught. So first has been generated. If we see the terms, we found that every term can be calculated from the preceding term by adding a difference, right? By adding a fixed number. So before updating the sum, I will have a step of calculate the new term, right? So it means I can initialize. I should have initialized a variable as a term. So first term is A naught, right? So I calculate a new term, which is A naught plus D. But I would write it should be term plus d, right? Since the first value of the term has been initialized as a naught, and this should be in the initialization, right? So then every time I will update the term plus d, right? And then I will update the summation as sum plus term, right? And this is the step that after initialization, I have to repeat for the number of terms. The first term is already there. So if I would like to calculate the summation up to n terms, so this process should be repeated for n minus 1 times, right? So this should be repeated n minus 1 times, right? So if you have initialized n, so it will run accordingly, and otherwise you can read the value of n and to get it done, right? So these are the initializations and all that, and just for completeness and to avoid all the confusions. I think at this step, calculate the new term. This is not appropriate over here. So this step should appear over here, which is this one. This one. Calculate a new term, right? So term variable, S variable, D variable, N variable, and all that. And how to perform the check whether this summation which has been performed in pieces is accurate. This can be done will be with the theoretical formula for n terms, and I hope I will be able to write it correctly. It is n by 2, and it is a plus or 2 times a plus n minus 1 times d, right? And in the program, you can then check, okay, this is the theoretical one. So when you come to write the program, you have to keep this one, that it is the formula sum. You have to define it with a different variable. So to check your program, you have to calculate the error, right? So S minus the formula sum, and since it is not a very sensitive kind of calculation where the errors come from the approximate representation of real numbers, so you are going to get something very close to zero. In case of integers, you are going to get a zero answer unless you add or you ask it to perform the sum for a very large number of integers where where it exceeds the precision and provided by the integer numbers. So that is the complete algorithm for the program. Uh, let's see that one in the complete form. Okay. Okay, here it is. So we started with the sum of arithmetic progression. We wrote its formula, right? And then we said it can be written like this, and we can identify that every new term can be calculated from the previous term by adding a difference. Well, this can be further written as in the indicial form, like a k plus 1 is equal to a k plus d value, right? So in programming, it is imperative that you should learn how to write uh, the generation of terms from the previous terms, right? So if you come to such a point, it means now you can develop the algorithm. You can say that this is valid for k values from 0, 1, 2, up to n minus 1 in order to generate the nth term. So this is something which is implemented in a different form, which is written as term equal to term plus d. So this type of algorithm saves the memory. Later on, you will learn the algorithms in which we declare a as a vector and we store all the values. This type of writing, like term equal to term plus d, it only preserves the last value, right? So the program generation has been demonstrated in two separate videos with the goto statement and if construct and with the do while statement. So I stopped the recording over at this point. So since you have been very silent and very patient during this time, so it's time to take a deep breath. It calms the mind.